Let's look at a very interesting application where Python can be used. Now here what we are doing is creating a program to do graphing of mathematical functions. Say sin x, cos x, tan x square, x cube. So plotting the graphs is a very interesting application. Now, normally what we would do is just create a minimum amount of code by which an expression can be plotted. Okay, now instead of that, what here we are going to do is we are going to allow the user to type in the expression and then do the graphing of that particular expression. So let's see how it will look like in the beginning itself, and then I'll take you through the code piece by piece. Okay, so here already entered is sin x. I have said np.sinx because I have kept the code simple in the sense if I just say sin x, it will say invalid expression because it is not able to find the sin x function using which it can generate a x and y values. But we know that it is available in numpy. So np.sinx, and if I click on plot, it plots a graph in a particular interval. Okay, I can change this. So let's say np.cos x. Similarly, np.tan x, which means that we can plot any function that is defined in numpy using np dot, no, 1 by np dot tan. Let's see what happens here. This should actually work. np dot tan x. Yes. Now here the intervals is not proper. That is why it is showing you like this. But if the interval is given properly, then it would plot properly. Now here again I have intervals coded, in the code itself, hard coded. What we could do is we could provide, proper interface so that the user can also manipulate the interval. Okay. I could also say X. For this, I don't require NP. Yes. I could say X square. I could say X cube. I could say X to the power of 1 by 2. That is square root of X, or Xth root of X. I could also do something like np.log of x, or np.e to the power of x. Let's see whether this works. Yes. So, and if I want to clear a plot, I can just click on clear. The only thing is in the memory it maintains all the previous graphs, so I can just keep clearing and I can close it off. It says come again. Thank you. Okay, now if you look at this, it is saying divide by 0 encountered in divide. Because what happens is when in certain functions, say for example, e to the power of 1 by x, so denominator cannot be 0. Luckily for us, it still plots the graph using the rest of the data set. What we could do is we could remove this 0 in the code itself before we plot it, in which case this runtime warning will not be possible. Okay, now let's go through the code which enabled us to do this. Normal, we have already seen window is equal to tk, so we created a window, we gave it a title, we gave it a size, we have configured the rows. So we have said row configure, 0th row of the window weightage we have given is 0. That means it is not going to be expandable. The first or the second row, we have given it the maximum weightage. And then we have something which we have not seen before, that is window.protocol. WM delete window, comma, on closing. So basically what happens is, when I click on that window close button, this function will be called. So on this particular event, this particular function will be called. And let's see what is happening there. Message box.showInfo, thank you, coming. Window.quit, window.destroy. So basically it is cleanly exiting the application. And then we are calling the graph plot and window.main loop. This is your standard. So graph plotter gets called. Now let's see what is happening in graph plotter. I have an entry frame in the window. Height is 2. Entry frame dot grid, I am displaying it, and I am saying to the north. Formula is equal to tk dot entry in this particular entry frame. Formula dot grid. Formula dot insert. Remember, when I ran the application, already np.signx was there. So I am inserting this np.signx into the formula entry widget. And then I'm saying focus, formula.focus, so that the cursor appears there. Then I'm setting up a button, tk.button in the entry frame itself. Command is equal to check formula, and I'm passing the formula and a parameter 1. Yes. And then I'm displaying that. Plus I'm also doing is I'm binding the return key to the formula, so that when I press enter after typing in the formula, it goes to the plot button directly. Strictly speaking, this is not actually a formula, it is more of an expression, because formula means basically you have a equality sign, but here we are talking of expressions. Okay, anyhow. So when I click on this button, check formula gets called. So let's go to check formula. What's happening there? Formula and that one that is passed, I'm taking it in X. Evaluate expression. Formula dot get. I'm getting the formula from that entry field. I'm initializing valid equal to true. And then I'm trying to evaluate this expression for x equal to 1. If it runs, that means it is a valid expression. Otherwise, if there is an exception, then I'm showing you this error message, and I'm saying valid equal to false. And then I'm saying if valid, plot the graph, and I'm passing the evaluation expression to the graph plot. Okay, so now let's go to graph plot. And here I am creating a frame for the graph. I am creating a figure. Now this is all related to the actual plotting of the graph. So I am creating a figure. Naturally, this figure will not be there in tkinter. So I would require matplotlib.pyplot. Myplotlib will be required. NumPy is anyhow required. Yes, for the message box, I require message box. I require this figure. So fig is equal to figure, and I'm setting up a figure size. If any of these expressions are true, if what he has typed, the expression that is typed in contains any of this sine, cos, or tan, I'm setting up, I'm generating a line space. I'm generating a x values from minus pi to pi. Yes. and this will give us the intervals between two numbers. And I'm saying PLT dot X limit is minus 2 pi to 2 pi. And I'm setting up a Y limit of minus 5 to 5. Now, if it is not a trigonometric function or the expression doesn't contain any of these three, then I'm generating a normal line space, right? Where I'm just generating from minus 10 to 10, and that interval is being divided into 100 pieces. So 100 sample size is 100 from minus 10 to 10. And again, I'm setting up a X limit and Y. Now, based on this X, that line space that has been generated, I'm saying evaluate the expression. So remember, this would contain, expression would contain something like, say, sine of X. And the X has these many number of values. So it will generate Y values for those X values. And then I'm creating or adding a subplot. This 1, 1, 1 is basically the positioning of the graph. Since I'm going to have a single graph, it will be there in the first row, first column, and that kind of thing. I'm setting up a horizontal line and a vertical line. These are your X and Y axis. Then I'm setting the ticks positioning, where the labels are. Labels means basically 5, 10, the each position's values is being displayed. So here I'm saying display it at the bottom of the x-axis, and similarly to the left of the x-axis. Okay, this I'm not going to use, and then I'm asking it to be plotted. So a plot has been created. Now I'm creating a canvas. Canvas is like a blank space within which things are created. So I'm creating a canvas using figure canvas PK AGG. So this is being imported from matplotlib.backends. Basically, this backends is, whenever we are talking of graphic, there are certain things that is happening on the user interface. But to be able to provide that, a lot of things are happening in the background, and that those functionality is provided in backends, matplotlib.backends. Okay, and here we are basically looking at setting up the canvas and providing a navigation toolbar. We will see what I mean by that. Okay, so, and this canvas has to be inside this frame. Then I'm saying canvas.draw, and then canvas.getTKWidget.pack. So it is going to be displayed. Now canvas.getTKWidgetPack, this is become a duplicate line. I have commented out certain things. That is why you have a duplicate. I'll remove those comments and then show you later. And then I'm setting up a clear graph button, which will clear the plot that has already been displayed, and clear graph.focus. So by default, the focus will be on the clear. Okay. So what happens? I type a expression and I click on plot graph. Check formula, it checks whether it is a valid expression or not. If it is, it passes the or calls the graph plot. And here the graph is displayed. So let's once again see how it would look like, right? Now here, if you notice, you just have the graph, but Matplotlib also provides you a toolbar that is taken care of by this, right, by the backends. And to show that, I just have to say toolbar is equal to navigation toolbar 2tk in this canvas and in this frame, and toolbar.update, and display the canvas again, or pack it into the canvas again. Not again, pack the toolbar in the canvas. Now let's see what the difference. F10 plot. Now at the bottom, do you see this toolbar comes up and it has some interesting properties. I can save this graph as a figure in these various formats. Okay, then I can zoom. So I can say I want to zoom into this particular area. So it looks like a straight line, but it's actually the sine function. I can do the panning, moving the graph from one place to other. So if I keep going up, I can look at various parts of the graph within the interval that I have defined. So let's see. Now here it would be much more clear. Yes, I can focus on different parts of the graph. Again, I can go back so that if I have done the panning, it will take me through all the parts where I have focused. And if I have done, say, something like this, I can directly click on home to get back to the main figure, main view. And I can move the cursor here and I can see the X and Y values at the bottom. So this entire thing is the toolbar. Okay. So I think you got the idea. So this is our graph plotter. Let's just review what all we have imported. We have imported tkinter, we have imported myplotlib, we have imported numpy. Yes, from tkinter we have imported ttk, from tkinter import message box, matplotlib.figure, matplotlib pyplot, and backends. See, many times what will happen is while you are trying out this code, you will say import. You'll import certain things, certain packages. Now, once you finish with your code, just review this again. It might happen that for some reason you imported something which is actually not required. So in that case, you can remove it off. Now, let's look at clear graph. It just destroys the graph. Okay, so that is plotting a graph. That's it. Bye.